Okay, this next section we're going to be using trigonometry as it's most commonly used for physics. Okay, and physics deals with vectors, which are either forces or velocities, things like that. Vectors represent a movement or a force. So it's not just a line, it's a direction with a magnitude. Okay, so these are all different representations of the same vector. Sometimes you'll see it in the IJ format. The I is your equivalent x direction movement. Okay? Same thing down here. This is the equivalent x direction movement. The real vector pushes things at this angle. Okay, but it's the equivalent of pushing something over 3 units and up 4, but it does both those things in one motion. Okay? So if I put something here, this vector is going to move it in this direction, this distance. Okay? So we can represent vectors in their component forms. Okay, the equivalent horizontal and vertical movement, or we can say we're moving this angle this amount. So this amount is called the magnitude, and the magnitude is just the length of the vector. In order to get that, we would just do Pythagorean theorem. So 3 squared plus 4 squared, it's 25. The square root of that is 5. So we could say vector PQ is this, or we could say PQ is magnitude 5 direction of theta. In order to find theta, we would have to do the tangent inverse of opposite over adjacent 4/3. We get 53.13 degrees. Okay, usually it would be stated force PQ, it would be named. So maybe it's wind blowing, or maybe it's a truck that's pushing something. Okay, it'd be force PQ has a magnitude of 5 at an angle of 53.13 degrees. Okay. Magnitude is sometimes written this way. So if I have vector v, this represents the magnitude, which again is just the length. Or we could write it this way. Okay, so we found the magnitude to be 5. And the direction, if they just say the direction angle, it's usually the angle made with a horizontal, unless they specify otherwise. Maybe they'll say it's 53.13 degrees west of south. Okay, that would mean that we're not going straight south. We're going 53.13 degrees west of that. So this would be our angle, okay, which we could still get our same right triangle and go from there. All right, so that's kind of the basic stuff for vectors. Once we have components for our vectors, we can combine vectors together. So if I have two vectors, u and v, so this would be the x component of u, x component of v, the y component, and the y component, I can do different vector operations. So I could get a force that's the opposite of u just by reversing both components. Okay, because now I'd be headed negative that many x's, which would counteract this, and negative that many y's, which would counteract this. Okay, a vector in its negative is essentially a vector of 0. I can combine two vectors together by adding their x components and their y components together. I can subtract. Okay, so if I have two forces acting in opposite directions, I can take the force in the x direction from this one and subtract the opposing force in the opposite direction. And I can multiply forces. Okay, so k is a constant. If I want to double my vector, I'd say 2 of these vectors would double both of my components. Now, if we start with a direction and an angle, the way we're going to get the horizontal and vertical components is by basic trigonometry. Okay, so if this is my magnitude and this is my angle, theta, if I just want to get the x component, okay, this is x, this is y, well, I would say that the cosine of theta equals x over r. So if I want to know just what x is, I would multiply both sides by r. So that means the horizontal component is r cosine theta. Okay, that's what the x component is. Sometimes you'll see it as, if I have vector b, they'll say this equals bx, so the x component of vector b. Okay, the vertical component, I would say the sine of theta equals y over r. So that means y equals r sine theta. Okay, and this is usually what you're going to have to use to combine forces and things like that. So let's take a look at an example. So let's say I have two forces that are acting on an object. One is pushing with 40 newtons at an angle of 50 degrees. Okay, so let's just draw this out. So I've got 50 degrees, and that's a force of 40 newtons. Okay, newtons is just the units for force, so that's capital N. The other is pulling. Okay, so one's pushing, one's pulling. That indicates to me that it's opposing. Okay, but it's 15 newtons at an angle of 175 degrees. So we'll do this in red. So I'm going to go 175 degrees, which is just shy of 180. Oops. Okay, this is 15 newtons at 175 degrees. Okay, so I've got these two forces. All right, so maybe this is a helicopter pulling on something, and this is, you know, a truck that's raised up off the ground, so it's a little higher, and it's pulling this way. We're going to see what the overall force acting on this object is. Okay, of course we're negating gravity because gravity would be pulling it straight down with its own force, but let's say we're in outer space. Spaceship's going this way, another one's going this way. Okay, this one's pulling with more force than this one is. Okay, so in order to combine these, I'm going to break them up into their components. So I want to know the x component of each one. So I want to know the x component of the blue. So the blue x component would be the radius, which is the magnitude, 40, times the cosine of my angle. Okay, and I want to know the x component of the red, which would be 15 cosine 175. I'm going to add these together to get the overall, the total x component of the resultant force. Okay, so I can just do this. I've got 40 cosine 50. I'm adding it to 15 cosine 175. Okay, now if you look here, 175, that's going to have a negative cosine value because we're over here. So I should get something that's smaller than either of these. So let's actually get the decimals out here. 40 cosine 50. Okay, that's a x component force of 25.71. Okay, so I guess that's blue. That's the blue force. The red is 15 cosine 175. Okay, so that's a negative. So when I add them together, I'm going to be subtracting Okay, and I get a total resultant force of, okay, I want to type it all in just so I don't round here. Okay, so this is my overall resultant X force. So we'll say the total X force would be 10.77. Okay, newtons, and this is in the X direction, so it's straight. Since it's positive, I know that it's this way. Okay, so I've got total X force 10 newtons to the right. Now we also need to do the Y force. Okay, so the Y force from the blue force is going to be 40 sine 50. The Y component of the red force is 15 sine 175. Both of these are going to be positive because we're both up here. So I should get something that's bigger than either one of these. So I'm just going to type them all in together. 40 sine of 50 plus 15 sine of 175. I get this. So I've got a total Y component force of 31.95 newtons. And that's going straight up. Okay? So to get the magnitude and direction of the resultant force, since I'm going 10.77 this way and 31.95 this way, I want just a single force that does both of those things combined. So I need to know the angle it's making and the magnitude. So I'm going to do Pythagorean theorem to find the magnitude. So 31.95 squared plus 10.77 squared, square root that. Okay, so that's the magnitude of my resultant force. So my total force actually equals 33.72 newtons at, now we need to find out this angle, so we do the tangent inverse of 31.95 over 10.77. .37 degrees. So let's take a look at this. So I had one spaceship going this way, the other spaceship going this way. Okay, so this was going at 40 newtons. This one's going at 15. So I ended up with a little bit less total force because those were opposing. But both my Y forces were going up. Okay, since I'm in these quadrants, they're both going up a little bit. So that's my total angle is steeper than both of these together, right? So I'd be going up this much. So I'm going up more. Okay, a little bit less force, but the overall result is to bring it up more than we were going over, because some of the over force has been canceled out, but all of the up force has been combined into a bigger up force. Okay, so that's kind of everything that we're going to be doing with vectors. So with this, you should be able to answer the rest of the worksheet.